This is a recorded reading of Building Your Knowledge Magnetic Fields. Before we begin, we'll be doing a pre-reading strategy by looking at the pictures and reading the captions. So I see a picture of a yellow bar with an S and an N at each end, and then I see lines around the bar, and then I'll read the caption in blue. The lines drawn around this magnet indicate its magnetic field. The strength of the field varies, and this is shown by how close the lines are in an area. I'll continue to scroll down until I get to the next image, and then I'll read the caption in blue. When two north poles are close together, the magnetic fields interact. As shown to the left, they interact differently when a north pole is close to a south pole, as shown to the right. I'll continue to scroll down, and I see this gray box here that tells me it's the end of the text. So that concludes the pre-reading strategy, and now we'll begin to read. Magnetic fields. Every baseball player knows that if you want to score a run, the bat must make contact with the ball. Some forces, such as the force of a bat on a ball, only occur if objects are touching. Magnetic force is different. Magnetism is the force exerted by a magnet on certain materials. A magnet exerts its force on another material whether the magnet and material touch or not. Why? Look at the illustration below. The area around a magnet is called a magnetic field. This illustration helps explain how strong a magnetic field might be. There are two words I want you to take note of, the word magnetic force and magnetism. Those are going to be synonyms. They mean the same thing, and that's the force exerted by a magnet on other materials. Another thing to note is that it says a magnet exerts its force on another material whether the magnet and material touch or not. This is through its magnetic field, and I'll page down in just a little bit. Close to the magnet, the lines are close. That means the field is strong. Farther away, the lines are not as close and the field is weaker. This means that the force is stronger the closer the magnetic material is to the magnet. Can you guess where the magnetic field is strongest? Notice in the illustration that the lines are closest together near each end of the magnet. Each end of a magnet is called a magnetic pole. All magnets have a north pole and a south pole. The field of the magnet is strongest at these poles. So what we'll do is we'll scroll down here and we'll start to write in some notes. Here's the image. So this N stands for North Pole, and it's on one side of the bar magnet. On the left side here is the South Pole, it's on the other side. Other magnets have poles, but they are going to look differently if they're not a bar magnet. Okay, so let's determine where the magnetic force is the greatest. So I'll just back up and say these lines here indicate the magnetic field, and this is how this magnet is able to exert a force on something it's not touching because of this field. And the lines, when the magnetic field lines are closer together, that means the magnetic force is stronger. And as you can see, the magnetic force is strongest on the ends because that's where the lines are closer together. So bar magnet is strongest on its ends, at its poles. Where the lines are farther apart, this is where the magnetic field, magnetic force is weaker. And you can see here in the center of the bar, it's going to be weaker than the poles. And the farther out you go, it's going to be weaker. And that is the strength of the force determines how much it influences a magnetic material. This image shows you how when two similar poles are near each other, they actually repel. And when the two ends that are similar are near each other, they are going to repel. So I'm going to put the word repel in here. And at the end of the North Pole, actually the magnetic force, this arrow determines the direction of the magnetic force. So the magnetic force wants to push out, and they're going to push out on each other. And when you have a North Pole and a South Pole, the North Pole wants to push out, and the South Pole wants to pull in. And when this happens, this is called attraction. This is the force that, this is called an attractive force, where the North Pole and the South Pole are going to be pulling together. You can also see in the illustration that the lines indicate the direction. Just like any push or pull, magnetic force has a direction. The lines point in the south towards the South Pole of a magnet out from the North Pole. The illustrations above show the effect of this force when you bring two magnets close together. If you bring the north poles of two magnets toward each other, they push apart. Two south poles would also push apart. But if you bring the north pole of one magnet close to the south pole of another, the magnet they pull together. But if you bring the north pole of one magnet close to the south pole of another magnet, they pull together. Since a magnetic field is the strongest close to the magnet, it's hard to push two north poles together or two south poles together, and it's hard to pull apart a north pole and a south pole that are stuck together. This concludes the guided reading for magnetic fields.